Machine learning, it's a term that's everywhere, right? But what's really going on behind all the hype? Well, that's what we're here to do. We're going to peel back the layers and get to the truth, the amazing potential, and also the tough, hard-learned realities.
You know that feeling when your bank pings you about a weird charge, like instantly? Or when Spotify serves up a song you've never heard but you absolutely love? It can feel a little bit like magic, right? Well, it's not. It's machine learning, and it's already woven into the fabric of our everyday lives.
All right, so here's the plan for this explainer. First, we'll talk about the ML revolution. Spoiler, it's already happened. Then we'll look at how it's changing everything. After that, we'll get real with a much-needed reality check, cover how to dodge some common mistakes, and wrap it all up with the real takeaway.
Okay, let's kick things off with the ML revolution. And look, the biggest thing to get straight from the start is that this isn't some far-off futuristic concept. Nope, it's here and it's happening right now.
So what are we actually talking about when we say machine learning? Well, at its heart, it's all about teaching computers to learn from experience, kind of like we do. Think about it. Instead of a programmer sitting down and writing code for every single possible outcome, which would be impossible, they basically feed a system a mountain of data and say, "Here, you figure out the patterns." That leap from being told what to do to learning what to do is a total game changer.
And because of that, well, this tech is completely reshaping our world. So let's jump in and take a quick tour of the promise of ML and see what it's actually doing out there in a few key industries.
First up, healthcare. This is a big one. Here, ML is kind of like giving a doctor a superpower, a sixth sense, if you will. It's helping us predict and treat diseases in ways that just weren't possible before. And the potential impact? It's just staggering. I mean, by sifting through these enormous biological data sets, ML can predict how different chemical compounds might work. This could slash the cost of discovering new drugs by up to 70%. Think about what that means, getting crucial, life-saving medicines to the people who need them, faster and way more affordably.
All right, let's switch gears to retail and e-commerce. In this world, machine learning is basically the ultimate personal shopper. You know, the one that knows exactly what you're looking for, maybe even before you do?
And does it work? Oh yeah, the results really do speak for themselves. One huge online retailer reported a 35% boost in sales after they rolled out their ML recommendation engine. So that you might also like section you see? It's not just a random guess, it's a highly sophisticated prediction engine, and it is driving serious, massive growth.
Okay, now for finance and banking. This is a super high-stakes game. And in this arena, machine learning is like a tireless digital watchdog, standing guard 24/7 to protect our money from fraudsters.
And you can see just how good this watchdog is. Look at these numbers from one bank, an 85% drop in false positives. You know what that means? Fewer of those super annoying moments where your card gets declined when you're trying to buy something legit. Plus, they're catching the real fraud 40% faster. It's just making the whole system safer and way less frustrating for all of us.
And last but not least, let's head over to the factory floor. You might not think of manufacturing as a high-tech playground, but ML is absolutely revolutionizing it with its predictive abilities. We're talking about optimizing pretty much everything.
Just look at this table. The numbers tell a really clear story. This one company brought in ML, and their defect detection rate shot up from 75% to 95%. That's huge for quality. But here's the real kicker. They cut down on equipment downtime and saved hundreds of thousands of dollars on maintenance. How? By predicting when a machine was about to break and fixing it before it did. That's the power of prediction. Okay, so we've seen all this incredible, world-changing potential, right? You'd think every single ML project would be a slam dunk, but that's not what happens. So why do so many of them end up falling flat? Yeah, it's time for a big ol' reality check. It's because it's just not that simple. That journey from a brilliant idea on a whiteboard to a working ML system in the real world, it's almost never a straight line. It's messy. And behind all the marketing buzz, the hard truth is that building this stuff is really, really difficult. So let's talk about the common traps that people fall into. First, there's something called data leakage. It's basically like your model gets the cheat on the test. It sees the answers while it's training, so it looks like a genius, but then it's totally useless out in the wild. Then you've got spurious variables. This is a classic. It's like building a model that thinks selling more ice cream causes more shark attacks, just because they both happen in the summer, right? They're related, but one doesn't cause the other. Another huge one is data drift. The world is always changing, and if your model doesn't change with it, its predictions get worse and worse. And of course, there's the simple mistake of just not retraining your models, letting them get stale.
And hey, this isn't just a textbook problem. Check out this quote from a user on Reddit. It perfectly captures that spurious variables issue. They said someone actually asked them to use lunar cycles to predict sleep interruptions. You can just imagine the eye roll, and their point is golden. Throwing in silly variables like that doesn't just do nothing. It actually makes the model worse by teaching it to focus on complete nonsense.
All right, so it's one thing to know all the ways a project can go wrong, but how do we actually sidestep these landmines? Let's pivot from the problems to the solutions. Here are a few pro tips for getting it right.
Here's a really great practical 4-step reality check you can use. Number 1, start simple. Seriously, the first question should always be, do we even need ML for this? Sometimes a basic rule-based system is way better. Number 2, question your data. I mean, really question it. Is it clean? Is there some hidden bias? Are there weird correlations? 3, do a real root cause analysis. When your model gets something wrong, don't just patch it. Dig in and figure out why it was wrong. And finally, number 4, manage your stakeholders. Your job as an expert isn't just to take orders. It's to guide the project with your knowledge and, gently steer people away from asking for things like lunar cycles.
So where does all of this leave us? We've seen the mind-blowing hype, and we've seen the painful reality. How do we bring those two things together? Well, it starts by accepting what machine learning really is, an incredibly powerful tool, but a tool that is far from perfect.
And this slide just sums it all up perfectly. The hype will tell you it's a magic bullet. The reality, it's a tool that takes real skill to use properly. The hype promises instant intelligence. The reality is it's completely dependent on good, quality data. People worry it'll replace humans, but the reality is that it augments humans, making us better. And maybe most importantly, the hype is all about the algorithm, but the reality is that success is about the algorithm plus the process plus the people.
At the end of the day, this is the truth of it. You can have the smartest, most complex algorithm on the planet, but it's going to fail if you don't have the right data, the right strategy, and the smart people asking the right questions to guide it. The tech is just one part of a much bigger puzzle.
So, to wrap things up, the big question isn't, is machine learning powerful? Because duh, of course it is, we've seen that. The real question is, now that we have our eyes wide open to its power and its pitfalls, what do we do with it? How can we be smart about using it to solve the problems that actually matter? What's the next big thing we should tackle?